Hi, I wanted to briefly go over this figure. I know a few of you have indicated it's a little complex, probably more confusing because it has so many different things in it. I have cleaned it up a little bit. I took away most of the pharmaceutical effects. I just left the hormones though. But anywhere where you see a negative or positive, just know that that's where we can manipulate the functionality of the nephron based on pharmaceutical effects. Okay, yeah, it's not something you really need to concern yourself with. The main focus of this and the main purpose of showing this figure is to help you understand the different functionality of the nephron in each section and the important components of that. Also so that you can see the difference that occurs in the osmolarity of the filtrate and how that also can fluctuate depending on circumstances. So the first thing I want to just mention, and I think most of you have this down, is the renal corpuscle is where we see the filtration occur, and that filtration does happen quite well. We're quite efficient at filtering our blood and getting the little things that need to go through. You don't want to spend too much time on that, but just know that once the filtrate is in the nephron tubule, we will go through these different sections and notice almost immediately in the proximal convoluted tubule you have a bunch of reabsorption. In fact, I would say all the vital things that you need, and that would include organic compounds like amino acids, glucose, water, ions, sodium chloride, potassium. All those are actually reabsorbed in the proximal convoluted tubule. 100% of the glucose is reabsorbed right here, once again, almost immediately, as long as the person's healthy and the blood glucose isn't too high. So that is also where we see a large bulk of the water be reabsorbed. Actually, 70% is already reabsorbed right there in the proximal convoluted tubule. And so, as you can see here, that secretion, vital secretion, things like urea may be secreted here in the proximal convoluted tubule, but its main functionality is reabsorption. And you can think of, once again, of those vital things, organic compounds, glucose, water, high reabsorption of water. Because all those things are coming out, we actually stay pretty close to the same osmolarity because we're taking water with us as well as a bunch of ions and so forth. As you get into the descending loop of Henle here, we do see more water leaving, and because of that, it gets a little more concentrated, and so we have this higher osmolarity. In fact, down here at the loop, it's actually quite high, and that's mainly due to recirculating gradient. So you do see some sodium and some chloride leave, and this is a big thing to always remember. Wherever sodium goes, water follows. So if sodium's getting reabsorbed, then water's also going to get reabsorbed. And we see, even though that's happening, it's happening at such a rate, the water reabsorption, that you have a highly concentrated osmolarity here at the loop, and so then water comes back through osmosis to start to dilute that, but then sodium and chloride and other ions are still being reabsorbed in, and so water kind of goes in and out, and that's kind of why we call it a recirculating gradient. But we still see, significant amounts of sodium and water being reabsorbed at this point. Now, you'll see here as we go up the distal convoluted tubule, up the ascending limb of the loop and into the distal convoluted tubule, that there's no water reabsorption. It just so happens these cells are specifically designed to not allow water reabsorption, and so because of that, even though we're still reabsorbing ions at this point in time, you're not seeing the water follow. And so because of that, once again, the osmolarity starts to diminish and get lower. We'll continue to go on and we'll discuss this in just a second, but here, the distal convoluted tubule, once again, we're still reabsorbing ions, we're still reabsorbing water. At this point in time, we see secretion depending on the needs of the body, of the acid-base balance and so forth. You may see some potassium secreted, you may see some hydrogen. Secretion then is putting things from the interstitial fluid into, specifically ions, toxins from the liver, so forth, are going from the interstitial fluid and from the vessels into the filtrate. So different from this filtrate over here, we're talking about this nephron filtrate that's inside. We'll actually see some secretion at this point in time. And then finally, with the collecting duct, we have our final reabsorption of ions and water and so forth. And so depending on our ionic balance and our acid-base balance will really depend, even though this shows it quite high urine collection, it may be more dilute depending on the needs of the body. And so ultimately to go to excretion. So the basic filtration, reabsorption, secretion, excretion, kind of shown here as the nephrons kind of spread out, so you can kind of see the difference there. Running out of time, but I just wanted to mention that the hormones, the antidiuretic, aldosterone, ANP, and angiotensin, which ultimately becomes angiotensin 2, all of these influence whether or not water is going to be reabsorbed in the distal convoluted tubule and the collecting duct. That's why it shows here this variability in the presence of aldosterone, ADH, and angiotensin 2. Over here we reabsorb more water. We're trying to increase blood pressure, and by doing so we increase our water reabsorption. ADH is a response to dehydration or the change in osmolarity, or osmolality as the case may be, and so if it's stimulated, that means we need more water in our system, not being excreted. On the other hand, ANP doesn't want extra water, so it will inhibit the water movement back to the vessels and back into our bodies, and will actually excrete it out. So the last section we have before you get into acid-base has to do once again with these 4 hormones. I hope that helps clear it up a little. I was trying to talk quickly because I don't have a lot of time, but for the video itself, since it does have its limitations, but hopefully that helps you understand what this figure was trying to say.